Okay, so in this video, I want to talk about the next section, which is annuities and savings plans. They also discuss stock tables, which is going to be a separate video. Okay, so this one, we're just really going to talk about annuities, okay? So annuities. All right, so an annuity is a series or a sequence of equal payments made at equal time periods. Now, the story behind an annuity is up until now, everything we've dealt with in personal finance, we've made one lump sum deposit. Okay. So if we're talking about any kind of savings plan where we were investing money, it was just one big lump sum. And oftentimes in the real world, that's not realistic. Okay. Like a lot of us don't have $50,000 that we can deposit all at once. So instead, what an annuity gives us is it gives us the opportunity to make smaller payments at equal time periods that will eventually accumulate to a larger savings plan. So again, it may not be realistic to come up with $50,000 or $60,000 today, but it could be realistic to come up with, say, $200 every month. Okay, so that is a reasonable way for us to save money. We come up with these kind of like payments to an investment. They're made at the same time. So like they'd be made each quarter or each month or semi-annually or each week. Okay. So they're going to be made at some equal time period. They're going to be in the same amount. And then at the end of some certain time period, so some set time period like 25 years, 30 years, 10 years, 5 years, whatever, at the end of a longer time frame, we look at the sum total of all of those deposits and any interest that has accumulated over time. Okay. So the value of the annuity is the sum of all deposits. Whoops. So it's the sum of all deposits plus any accumulated interest. And again, this is kind of a reasonable or a realistic way for many people to save and plan. So it's a reasonable or realistic way for people to financially prepare for the future. Well, I can't spell, but that's okay. Now, there are different types of annuities. You'll hear in a lot of these problems, you'll talk about an IRA, which is just a type of retirement plan. Again, a lot of these problems are going to be retirement type plan problems, but it doesn't have to be necessarily for retirement. You could know that you're having kids and you want to plan for them to go to college. You could know that you want to have a big, I don't know, anniversary party or a big vacation at a certain time down the road. And this could be a realistic way to plan for that. So again, this is no longer one large lump sum deposit. Okay, instead it's going to be smaller payments towards a bigger goal. Okay, so the formula is nasty, okay, but we will go through it nice and easy. So the formula, we're talking about the future value of the annuity. So we're talking about A. You want to take P, the present value. So P is going to be the value of your deposits, those regular deposits that you're going to make. We're going to multiply that by 1 plus whatever interest rate you're investing at, divided by the number of regular payments you're going to make per year. So that's kind of like your compounding period. We're going to put that in parentheses and round it to the n times t power, where n is the compounding period or the number of regular payments per year. T is the number of years. We subtract 1 from that, and that is the numerator. So that whole piece right there is the numerator. And then we're going to divide that by the interest rate divided by the number of payments per year. Okay. And just to make sure everybody's clear, A is the future value of the annuity. It's how much the value or how much the annuity is worth so many years down the road. P is the value of the regular deposit. R is the interest rate. And just like with all of the other problems we've dealt with in this section, R is going to be used as a decimal, okay? So we do want to make sure the interest rate is converted to its decimal form. N is the number of payments per year, number of payments, or you can call them deposits. And T is the number of years. Okay, so let's look at a problem kind of, we're going to look at a really, really easy one where you're just going to make one payment per year. Okay, so in this particular situation, we're going to say $2,000 is deposited annually into an annuity that pays 10% per year. All right. How much will the annuity be worth in 3 years? We're also going to calculate the interest. Calculating the interest on an annuity is quite different than calculating interest before, because in a lot of those previous examples, we calculated like the future value of a loan or an investment, and then we could just subtract that one annual deposit or that one monthly, or not that one annual, but that one lump sum deposit. Here it's a little different because we first have to calculate how many regular deposits we made, whether annually, semi-annually, weekly, monthly, quarterly, whatever. Then we take that and subtract it from the grand total that's in the account. Okay. So it's a little bit different here. All right. So first of all, let's go ahead and use this formula. We have $2,000. That's going to be our P. We are calculating interest annually. So we're going to make that one annual deposit. So this is your N. All right. We have an annuity that pays 10%, which I do want to be clear. You're not in real life going to find an annuity that pays 10%. Okay, the interest rate is going to be significantly less than 10%. But with all that said, this is R. We're interested in how much is in the annuity in 3 years. So that is your T. We want to find A. Okay, so A is going to equal 2,000 times 1 plus 0.10, that's R, divided by N, which is just 1. Remember, we're making one payment a year. We're going to raise that to the N, which is 1, times T power, which is 3. And then from that entire piece, we're going to subtract 1. And all of this is over the interest rate divided by the number of payments per year. Okay. So in this situation, because N is 1, we could simplify the formula a bit, but I want you to get used to just using this one formula. I don't want to confuse you with several different formulas. So just know that the R divided by N simplifies really nicely here. Okay. Now we are going to have to go to the calculator. So I'm going to have to switch screens. So make sure you pause the video here and write this down so you have it when you go to your calculator. All right. So I'm going to switch the share and I'm going to go to the calculator. All right. So the best way to type in some of these more complicated formulas would be to set up your calculator to accept a fraction. Okay. It just makes it easier where you don't have to deal with quite so many sets of parentheses. So to do that, you hit the green alpha button and then you hit Y equals. The very first thing that pops up is the fraction. So hit enter. Keep in mind, this is just one way to type this in. There are other ways to get your calculator to accept a fraction, but I find this is the most general one that works for most types of calculators. Okay, so for the numerator, we wanted to type in the amount of our deposit, which is $2,000. I do need to set up parentheses, and then I immediately want to set up another set of parentheses. So I'm going to hit parentheses twice, and then I'm going to go 1 plus R divided by N is 0.1 divided by 1. All right. I want to end that internal set of parentheses. I want to raise it to the N times T power, which is just 1 times 3. And then I'm going to move to the right of that, and I'm going to subtract 1. I'm going to end the parentheses for the numerator. I'm going to go down to the denominator, and I'm going to type in R, which is 0.1, divided by N, which is 1. And I'm going to make sure that's in parentheses too. You don't technically have to put the denominator in parentheses. I tend to over parenthesize, so I do. Okay. So then I would hit enter. And that's going to tell me the value in this annuity after 3 years. So we get $6,620. So again, make sure you pause the video here and look to see how I typed this in. You want your calculator to match. And I'm going to go back to the whiteboard. And we have that the value of this annuity is $6,620. Please understand this is all deposits and interest. So this is the grand total of that account after 3 years. The next thing we want to do is figure out how much of this account is just interest. Okay. So how much is interest? Well, we know the grand total when we use that A equals formula. That's everything in the account, interest and deposits. So we want to take the grand total, $6,620, and we want to subtract everything that we put into that. So we made $1,000 or $2,000 deposits once a year for 3 years. This is the grand total of what we put in it. So this is what we deposit. And when we subtract here, that's going to give us the total that's just interest, okay? So 6,620 is the total amount in the account, okay? We made $2,000 deposits once a year for 3 years, so we ended up making a grand total of $6,000 worth of deposits to this account. When we subtract, there's $620 left. This right here is interest. And you absolutely need to know how to take an annuity's future value and split it into what you put into the annuity versus the interest that accumulates over time. Okay, so this right here, this is a common calculation that you would be asked to complete. Okay, let's look at another example. All right, so next up, suppose that when you are 25, you deposit $3,000 into an IRA, that's just an individual retirement account, at the end of each year for 40 years, okay? So at age 25, you deposit $3,000 into an IRA. Again, that's just a type of an annuity. You do this at the end of each year. And you do it for 40 years. So the plan here is to make this annual deposit every year for the life of your career, basically, hoping that you can retire at age 65. So we're going to do this for 40 years. Okay. If you cannot, let's see, if you can count on an interest rate of 8% compounded annually, how much will be in the account when you retire? Now, I do want to remind you that an interest rate of 8% is really, really high. You're probably not going to find anything remotely close to that. So don't think you're suddenly going to become a gajillionaire. Okay, just FYI. All right, so at the age of 25, you want to start making these annual deposits. $3,000, that's going to be your P. That's going to be the amount of each deposit you make. You want to do this for 40 years, so this is T. All right. Interest is going to be compounded annually. So that's your N. That just means you're making one payment per year. Okay. And let's see, 8%, that is our interest rate. Okay. Now, the best way to remember these formulas is to use them every time or to rewrite them every time you use them. I do not expect you to memorize these formulas. You will have access to these formulas on your final. So don't put too much brain power into memorizing the formulas, but I would still write them down every time you use them so you can help remind yourself when to use them, because that is what we're testing you on. Do you know which formula to use when and how to use it? Okay. So we have A equals, remember, P times 1 plus R over N raised to the N times T power minus 1. All of that is over R divided by N. So for us, this is going to translate to 3,000 times 1 plus 0.08, that's our interest rate as a decimal, divided by the compounding period, which is just 1. We're making 1 payment per year. We're going to raise that to the N, which is 1, times T, which is 40 power. I'm going to subtract 1 from all of that, and then the entire thing gets divided by R over N. Okay, so again, pause the video, make sure you have this written down, and then we're going to jump over to the calculator. Okay, so just like before, I'm going to do alpha y equals. I find that's just the easiest way to type in one of these kind of complicated formulas that looks like a fraction. So I'm going to go alpha y equals, and I'm going to choose the first option. For the numerator, we were making a $3,000 deposit. I'm going to do my double parentheses right now. And I'm going to go 1 plus R divided by N, so 0.08 divided by 1. You could put 0.08 divided by 1 into a fraction again, or just leave it like this, whichever you prefer. I'm going to end the internal set of parentheses. Then I'm going to use that caret button, which is above the division button. That's going to raise me up to that exponent world. And I'm going to raise it to the N times T power, N being 1 because we're making 1 annual deposit a year, T being 40. I'm going to go back down to the main part of the problem, and I'm going to subtract 1. You want to make sure when you subtract 1, it's not in your exponent, okay? End the parentheses for the numerator. And then for the denominator, again, I tend to over parenthesize, so I am going to put my denominator in parentheses. You don't really have to, though. So it's 0.08 divided by 1. And then I'm going to hit enter. Now, with annuities, read the question carefully, because oftentimes with annuities or house payments, I don't want to say oftentimes, but frequently, you'll see them ask you to round to the nearest dollar. Okay. In this case, we're not going to round to the nearest dollar. We'll go ahead and round to the nearest cent. But with annuities, please do read the question carefully, because sometimes you will be asked to round to the nearest dollar. So it looks like after 40 years, we'll have $777,169. And the change part of this is going to round to 56 cents. Okay. So let's see what that looks like on the whiteboard. Okay. So again, this rounded to $777,000. $169.56. Okay, so let me say that better. This rounds to $777,169.56. Okay, so let's practice interest again. So how much of the account is interest? Well, we want to take the total value of the annuity, which we just found. This is the total value of the annuity. All right, so we're going to take the $777,169.56. We want to subtract everything that we put into that account. We deposited $3,000 once a year for 40 years. Whatever's left over is going to end up being the interest, okay? So let me get my handheld calculator here. I don't want to switch back to the other screen. So we have $777,169.56. The total of our deposits end up being $120,000. So this is our deposits. And when we subtract 120,000 from the value of the annuity, we are left with $657,169.56. So this is the interest. I can't say it enough. Don't think you're going to suddenly make $650,000 in interest. An annuity doesn't generally have an interest rate of 8%. Okay. All right, let's look at another example. Okay, so this one says at age 30, to save for retirement, you decide to deposit 100 at the end of each month into an IRA that pays 9.5%. So at the age of 30, to save for retirement, you deposit 100 into an IRA at the end of each month. We'll say that the IRA pays an unrealistic 9.5% compounded monthly. The compounding period is going to match the number of deposits you make. Basically, you'd make a deposit, interest is calculated. So compounded monthly. How much will you have when you retire at age 65? All right. So let's go through. We're going to piece this together. We're going to figure out all the different variables. We're making $100 deposits. That's the P. We're doing this at the end of each month. So that's going to kind of indicate that N eventually is going to be 12. Our interest rate is 9.5%. So that's our R. Compounded monthly again is N. And then we have to figure out what T is. So we're not told flat out what T is, but we've got the information to figure it out. We start making deposits at age 30. We make deposits until we're 65. So 65 minus 30 tells us that T is 35 years. Okay. So again, we had A equals P times 1 plus R over N raised to the N times T power minus 1 all over R over N. So more specifically with our numbers, we're going to have 100 times 1 plus 0.095 divided by 12, okay? We're going to end the internal set of parentheses. We're going to raise that to the 12 times 35 power. We're going to leave the exponent and subtract 1. And then this entire expression in the numerator is going to get divided by 0.095 divided by 12. Okay. So at this point, pause the video, make sure you have this written down, and then catch up with us when we go to the calculator. Okay. So for this calculation, again, we're going to go alpha y equals, we're going to choose option 1. Okay. For the numerator, remember we're making $100 deposits. So 100 parentheses, parentheses. 1 plus 0.095 divided by 12. That's R divided by N in the internal set of parentheses. You then want to raise this to the 12 times 35 power. That's your exponent. We're going to leave the exponent, just hit the right arrow, subtract 1. In the external set of parentheses, we're going to go to the denominator, and it's going to be 0.095 divided by 12. And then hit enter. And for this one again, well, no, for this one, let's just practice rounding. Do I want to round to the nearest dollar? Let's round to the nearest cent one more time. And then for the next example, we'll round to the nearest dollar. So for this one, we're going to have $333,946, and it looks like 30 cents at the end of 35 years. Okay. So let me write that down so I can translate it to the next page. So 333,946.30. Let me make sure I have a different number in my notes. So I want to make sure I typed it in correctly. Yeah, we're good. Okay. Let's go back to the whiteboard. So make sure you get this number written down correctly. I'm sorry I have to bounce back and forth between screens. My technology at home is fairly limited. All right, so the value of this annuity is $333,946.30. All right, so this is the total value of the annuity. All right. And just for fun, let's see how much of this is interest. All right, so remember, you take the total value of the annuity, which is $333,946.30. We want to subtract everything that we personally put into this annuity. So all of the deposits we made, we want to subtract out. We deposited $100 every month, so 12 times a year for 35 years. So let's see what that ends up equaling. Excuse me. So that's $42,000. So we have $333,946.30. We want to subtract $42,000, which was our own money. And anything that's left over would be interest. So I want to subtract 333,946.3. All right, so we're going to end up with $291,946.30 in interest. So this is the interest, and this would be our deposits. Again, I do want to say it one more time, 9.5% interest is ridiculous. Okay. So there you have it. That's the calculation to determine how much of the account is interest and how much of the account is your own deposits. Okay. Let's look at one more example. So in this example, we're going to try to determine what we would need to deposit in order to have a specific amount in the future. Okay. So for this problem, this is planning ahead. Let's say you know your future goal. You need to find or determine the regular payment amount or deposit amount to reach this goal. So you know the opposite. So in this case, let's say when you retire, you know you want to have $750,000 to retire on. What would you have to deposit each month or each week or each quarter in order to reach that particular goal? Okay, we do have a slightly different formula here. Okay. So in this case, we want to know what P equals. We don't know the amount of our regular deposit. We just know that future goal. So we have P equals A times R over N. That's your numerator. And your denominator is 1 minus R over N raised to the N times T power, and then subtract 1. So basically, we took that previous formula and we just solved for P, which gives us this formula. So all of the variables are the same. P is the value of the deposit. A is the total amount of the annuity. R is the interest rate, always as a decimal, don't forget that. N is the number of deposits per year. And T is the number of years. And there's one thing you always have to remember when you're calculating one of these formulas for P, where you're using P equals, you're doing that future planning. You always round up to next cent or next dollar. All right. So I promised you for this one, we would go ahead and practice rounding to the dollar just because it will come up from time to time with an annuity. So let's look at this example. Parents of a baby girl are in a financial position to begin saving for her college education. They plan to have $100,000 in a college fund in 18 years by making regular end of the month deposits in an annuity that pays 9% compounded monthly. Again, 9% is way, way higher than is realistic. Okay. So basically, parents want 100,000 in 18 years to send their daughter to college. They need to determine the value of regular monthly payments to be made into an annuity that pays 9%. Okay, so let's figure out what each of these variables are for. And ultimately what we're looking for is we want to know the value of the deposit, and then we're also going to calculate the interest. Okay, so $100,000, that's our end goal. That's not the regular monthly deposit. My God, that child would have a gazillion dollars at the end of 18 years. This is how much they want to have in 18 years. So this is your P, 18 is your T. They need to determine the value of regular monthly payments. So that tells you N is 12 and the interest rate is 9%. Okay, so remember our formula is P equals A times R over N divided by 1 plus R over N raised to the N times T power minus 1. Okay, more specifically for this problem, we have P equals 100,000 times 0.09, that's the interest rate. We're making monthly payments, so 12 is going to be our N value. We're going to start parentheses in the denominator, start parentheses again, and then we get 1 plus 0.09 divided by 12 raised to the 12 times 18 power minus 1. Okay, so just like before, go ahead and pause the video, make sure you get this written down, and then we'll look at the calculator. Okay, so for the calculator, just like the previous examples, I am going to set the stage for the fraction. It just makes things a little bit easier. So I'm going to go alpha y equals. I'm going to choose option 1. Now, the numerator for this problem was $100,000. We're going to multiply that by the interest rate, which is 0.09, divided by the compounding period, which is 12. That's my numerator. I'm going to drop down to the denominator. I'm going to start the external parentheses, then the internal parentheses, and I'm going to go 1 plus R, which is 0.09, divided by N, which is 12. I'm going to end the internal set of parentheses. I'm going to move up to that exponent world. So remember, directly above the division button is that little caret button, which looks like kind of an up arrow. That raises you to that superscript world. So then I'm going to multiply that by N, which is 12, times T, which is 18. I'm going to leave the exponent and subtract 1. And then I'm going to end the parentheses. Whoops. I'm going to end the parentheses for the entire denominator. Okay. Now for this one, let's round up to the next dollar. So even if mathematically we should round down, when you're solving for P, round up anyway. Okay. So we hit enter. And we get $186.44. That's how this would round mathematically, okay? It would round to $186.44. Rounding to the nearest dollar, this would round to $186. But we're looking for P, so we want to go ahead and round this up to $187, okay? So again, let's go to the whiteboard. So technically this rounds to $186.44, which is $186. But we are looking for P. Rounding up, we get $187. So these parents need to come up with $187 at the end of every month for 18 years, and they should be able to reach their goal of $100,000 for their kids' college fund. So how much is interest? Well, at the end of 18 years, we should have at least $100,000. Okay, since we rounded up, we may have a teeny tiny bit more than $100,000, but we're going to go ahead and say that we're going to have at least $100,000 in this account. Okay, that's the total value of the annuity in 18 years. We made regular monthly deposits of $187. So we would multiply 187 by 12. That gives us the monthly deposit. Then we want to multiply this by 18. So let's see, our total deposits, if we do 187 times 12 times 18, we ended up depositing a total of $40,392. When we subtract that from 100,000, that'll tell us how much interest we would have gained over the last 18 years. So with this scenario, we would have earned $59,608 in interest. So $40,392, that's the total of our deposits. And then $59,608, that's the total interest that we earned. Okay, so that's pretty much it for the annuities. You would have to really calculate two things. What is the future value of the annuity? So that means you know how much you can afford each month or each quarter or each week, whatever that regular deposit period would be. You need to determine how much you'll eventually have in your annuity. The other thing that we could do is exactly what's still on the screen here. We know what our future goal is. So we know that like down the road, we want to buy a house, we want to buy a car, we want to go to college, we want to plan for retirement, whatever the case is. We know how much money we need in the future. We need to figure out the amount of the deposit that we could afford to make to meet that goal. Okay, so those are the two things you do with an annuity. The second video, so the part 2 of this is going to go over what a stock table looks like. All right, hope y'all are doing well. All right, take care.